Hey everybody, welcome back to the channel. Today we're going to be doing, we're going to sharpen this dovetail cutter, but we're also going to do a bit of a deep dive into how it was manufactured, why that matters to us, what exactly is it that lets us know this is dull. I'd like to invite you guys to stick around to the end of this video because we're going to be introducing a cool new feature to our channel. These teeth on the end here, they had two angles. There was an angle from the outside coming in that's normally about 3 degrees, and there was also a second angle from the leading edge towards the back, which would normally be 5 to 7 degrees. And if you look out here near the outside, you can see that it's worn both of those angles away. So basically, if you ran a dial across this surface, you'd get a reading of 0 the whole way. And so it has no more clearance angle, and this thing is just going to rub, create heat. It's just not going to work like this. So the first step is to recreate this 3-degree angle this way and the 5 to 7 degree angle. I mean, we'll dial it and we'll recreate exactly what's there, and then we'll recreate these and we'll get that cleaned up right out to the tip or close to the tip, and that's going to be our first setup. I can tell by looking at this that these flutes and tooth faces were machined in when this thing was still in its soft state, and then it was hardened, and then the grinding was done. So all these dull surfaces here were machined when it was in its soft state, and then after hardening, the shank itself was ground, and then these clearance angles were ground on the teeth themselves. One thing that's like super important to note here is that these tooth faces, they pass exactly through the center line of the tool. And the reason that's important is if they were not through the center line, because this is an angle, it would be incredibly difficult to make this thing be exactly perfect. But because it's on center line, that gives us a starting point where we know we can recreate this exactly.
Speak to me.
There's going to be 3 setups to sharpen this thing. The first setup we're going to make is to redo these clearance angles here. And again, this is 3 degrees this way and probably 5 to 7-ish this way. So the first setup we're going to do is to do that. The second setup we're going to do is to sharpen and redo these clearances here. And then finally, at the end of it all, we're going to put a very slight radius between this angle and this angle. The reason we're doing that is if this was left perfectly to a super sharp little point, that would not be the least bit durable. That little point would wear round, just like what we have here, and the thing would be dull in no time. But by putting a nice little radius on here, probably 20th thou or so radius, that's going to really make this corner a lot more durable. So the first thing I'm going to do is use this sensitive work head to get this thing set up. And because we know center is so incredibly important with tapers, I'm going to get this thing dialed in perfectly flat, and that way we can use our height gauge to rotate this until this tooth face is exactly on the center line of the whole machine. So I'm using the graduations on this. I'm going to set it to 0. Now, of course, we won't trust that. That doesn't actually mean that it's perfectly dialed in. We actually have to get a dial and get that dial running 0 on a piece of material in the collet that is running true. So to dial off of something, I've just got this, just an arbor, a tool holding arbor, a workpiece holder, but it's hardened, it's ground, it's perfectly straight and true. So this will make a perfectly good thing to dial off. So we're running 0 this way. I'm going to put my dial in this position. We're going to get it running 0 that way. And now we're running perfectly zero this way, so we can carry on with our setup. This indexing plate that I have for the sensitive workhead has 24 divisions on it. So, I mean, that's good if you're doing numbers of flutes like 2, 3, 4, 6, 8, and 12. Well, this tool has 10. So we're not going to be able to use this indexing plate. And this is the only indexing plate I have. Because this has 10 teeth, we're going to have to index directly off the cutter itself and use its tooth faces as our indexing plate. So this is exactly the center height of the machine. Now I want to get the face of this tooth at that same center height. And then I'm going to come in with this pointer, and I'm going to get that set up so that I can index off of my tooth face. So this pointer is what I'm doing my indexing with. And I'm just going to snug that in place, and we're going to double check that the face of that tooth is exactly at the center height of the machine, and it is. So now we're confident that this tooth is exactly on center. Now we can spin this thing any which way we want, which is what we need to do to get set up for cutting these angles. Now that we know that this tooth face is perfectly on center, we can rotate this this way, and we can also move it up and down anywhere we want, and we're still going to have this face on center. So I'm estimating that this angle was 3 degrees and this angle was between 5 and 7. So I'm going to use the graduations on this fixture. And I'm going to start by swiveling the base over to 3 degrees. And then I'm going to tip this up. Oh, let's go 6 degrees for starters. And now we're going to dial all the way around this surface until we get it running zero. Of course, we won't dial out where the damage is because that'll give us a false reading. We're only going to dial where the tooth clearance is still intact. So there we're pretty much running zero. Turns out that that was only 1 degree. I guessed 3 degrees. It's actually 1 degree. So now we'll go up and down and we'll dial this direction in. So you can see we're a little minus at the bottom, we're a little plus at the top. I'm at 6 degrees now. I'm going to go 1 more degree up to 7, see if we can get that running perfectly zero. Yeah, so up and down we're good. We're at 7 degrees. Out here doesn't matter, remember, because it's all worn. There we're about a half a thou. This tiniest little adjustment here. So now we've picked up the 2 clearance angles on the end of this thing. We're running 0 back and forth and 0 up and down. So that's going to be pretty much perfect. Now I'm going to take this is a dish wheel, and basically, so what that means is that there's an angle to the wheel this way. So that as I'm grinding things with it, the very edge touches and the rest of this is clearance. So it won't touch. And what we're going to do is put that wheel in here so that as we come over with our table, that's going to nestle right into there. We'll stop it there before it hits the next tooth. And that'll be our grinding action right there. Now as I'm adjusting this thing, I don't want to lose track of my center height, so I'm going to reset off of this tooth at its current height, set a 0 there, and make sure after I do my adjustment with that finger pointer that I'm still coming exactly back to 0. Okay, so we're all set up. This tooth down here that the indexing pointer is touching is still, that tooth is perfectly on center. We do clear, the wheel nut clears the pointer assembly here.
Okay.
And you can see here, this wheel is gonna clean that tooth up and stop shy of hitting the next tooth, which is super important. And now another thing I want to mention is that this pointer, it's not as rigid as when we point off of this indexing plate. This thing is like, it's solid. Like you click into one of these notches and you're there. There's no messing around. You can see here, there's flex in this a little bit. So you see, I can force that to be in the wrong place. So as I index, I'm gonna have to have incredibly gentle feel on this thing so that each tooth, in fact, does get ground exactly at center height.
Setting up the sucker.
Yep. Let this thing breathe in all the dust so we don't have to.
Sounds like a plan.
So as I touch off, what I suspect we're going to see, because we dialed it 0 this way, and we dialed it 0 this way, so this whole patch here, everywhere except where the damage is, this whole patch should clean up just about all at the same time. I hope that's coming across, but we did actually clean that whole patch up all at the same time. So that's just about exactly what I wanted to see. So we've got most of the damage cleaned up. Now I am going to redo these angled clearances as well. That'll take some more of this damage away. And then we are going to put a radius on here in the end. So I'm going to stop there now because, as you can see, I'm starting to run kind of low on flute here. There was quite a bit of damage on there. So I'm going to call this good for this setup, and I'm going to set up to do the sides. I'm just starting to work on the next setup to do the outside diameter, to sharpen the outside diameter of this thing. And it's going to end up sitting about like this. That's what's going to give me this angle. But for starters, I need to get it running again, perfectly 0 this way with my dial and perfectly 0 this way with my dial, so that once again I can set the exact perfect center height of my tooth face. Eyeballing that angle for starters, we're going to end up dialing it in, but this is the point at which I want to set my tooth face at exactly 0, so we're going to use the height gauge to do that. So there we are. Tooth face is at exactly 0. Awfully darn close. So now we can dial off the back of that tooth and pick up our angle. There you can see we're perfectly dialed in. We're coming on the tooth there, and there's the back of the tooth. And that dial's not budging. So we know we're going to exactly recreate that 30-degree angle.
No more cup wheel?
I put the dish wheel away. This is a plain style wheel, and we're going to be using this edge to create our clearance angle. We're going to have the wheel height below the center height of the tool, and so you can see as you drop down here, you can adjust your angle based on where it is you're touching. So I mean, I have the wheel just randomly below 0. I'm going to just rub into it, the slightest little bit there, and now I'm going to pull it out and I'm going to see where I was touching. So I've made a bunch of adjustments, just trial and error, wanting to get this thing where it needs to be. See that line right there? So I was way too high, touching just here, and I did a bunch of different touch-offs. I kept moving the wheel lower on each touch-off, and now my line from top to bottom is pretty even.
I could see it.
So now what I need to do, because we know this tooth is at perfectly center height, and what I need to do is get my pointer somewhere on that tooth face so that it won't interfere with the grinding wheel. So now I'm just double checking that through all that setup. See, so my height did move a little when I set this pointer up, so I'm going to make some adjustments here. Okay, so here guys, we have our pointer allowing us to index, and then I know you're not going to be able to see the face of this dial. You just have to trust me that this is right back on 0. So I'm not going to be able to get this dust collector exactly in line with the trail of sparks that's going to be coming off of here, but at least it running will cause the air to generally travel in that direction. Keep the air a little cleaner for us. I am going to knock this corner off this wheel because you can see by the time the edge that's going to cut comes off of the tooth that was cutting, this back side of the wheel is going to want to hit that shank. So I'm just going to throw a little 45 on here so it clears. And now you can see that with that angle on the wheel, it's not going to hit the shank anymore. So I've touched off to the wheel without it spinning, just by hand, like moving the wheel by hand until it just touched. So now what I'm going to do is I'm going to take a pass across that tooth, and what we should see, if all of our dialing was exactly bang on, is we should see that we're taking the exact same amount of material off all the way down that tooth. So let's see what happens. Yeah, I would say that's just about perfect. If you look at these teeth, you can see that we also did a decent job of setting our clearance angle up. because it's not hitting more at the front or more at the back. It basically, with the first valve, it cleaned up all the way from the front to the back. So we've recreated the angle exactly this way, and we've also recreated the clearance angle exactly. Okay guys, so this is basically roughed down. You can see up here, I hope you can see, there's just the slightest little witness of the original damage that was on here. And of course, we're going to finish that off with a radius. So I'm not worried about that. Now that I've got this down as far as it needs to be, these edges are all nice and cleaned up. I'm just going to do one more lap, but I'm going to feed my table across very, very slowly so I get a super nice, fine finish on here. You can see this pass, I'm moving much more slowly than I was when I was roughing it down. So that's our second setup done. We did our end first, now we've done our sides, and now we just have to put a radius on this very corner to blend the side nicely into the end and make a corner that's more durable than this pointy corner here. So I'm going to use some of this setup for the next one. So basically what I'm saying is, we know how important it is that I have the tooth at the center height, and right now it is exactly at the center height. So I'm going to lock this spindle with the tooth right there, and then that'll be one less thing I have to get dialed in when I do the next setup. Third and final setup is putting the radius on the corners. So I've got my radius grinding fixture up here. This tool is for setup. So this taper at the center of this device is the exact center of rotation, and this with the sides cut away, so this actual edge is the exact center of rotation. So what I've done for starters is I've got my wheel centered to the fixture, which is really important. That's like the first thing you do, because after you get a tool in there, you won't be able to do that. I've also got this, the rotation of this is locked out, and I've got it so that when I run a dial in this T-slot and run this hand wheel, I get a 0 reading along here. And that's important because as I advance this to create the radius, I don't want it coming in at an angle, because then that'll change everything. That'll change how everything's working. Now here I've taken my sensitive workhead off of its base, and the reason is I'm going to be mounting that up on here, and then we'll get it running true to the cross slide of the machine, and then we'll be able to actually touch off and accurately create the size of radius we want to. So now I'm dialing this sensitive workhead in so that its center line is running true to the cross feed of this machine. So I'm coming up, what I want to do is I want to get as close as I can, that exact corner of the tool aligned with this edge of this alignment tool. And then once I have that in that position, then I can actually make the offsets to the fixture that'll give me the radius I'm looking for. Well, now it's time to actually make the offsets on the radius grinding fixture to give us the radius we want. Now, I've got a slot drill here, and if we were putting this radius on the slot drill, when we touched this corner off to that setup tool, then we could simply move 20 thou in this axis and 20 thou in this axis, and that would give us our nice radius on that corner. But because this, it's got a 30-degree angle here, so what I've done is I did some math, a little quick trigonometry, and I've learned that as this comes 20 thou in this direction, it comes 11 thou in this direction. So I'm going to touch off at this corner with the pointer. I'm going to go my 20 thou in this way, but then I'm going to go 31 thou over this way, and then the end result will be a radius that pretty nicely blends into both of those surfaces.
Can't see.
No. So what I'm going to do, I'm going to use a piece of paper, and then at least I can feel it.
Oh, I hear it.
Yeah, so there's that one. And I'm going to set a 0. Well, first of all, the paper is like 4 thou thick, so I'm starting 4 thou before the 0. Now I'm coming to my 0, and now I'm going to go 10, 20, 31 thou on that one, and that should be where that belongs. And now I'm going to touch off in this axis. I can feel it getting tight there. So now I'm going to do the same thing. I'm going to set this for 4 thou before my 0. I'm going to come to my 0, and then I'm going to move my 20 thou. And that should be it. That should put that radius exactly where we want it for the best possible blend. I'm just getting my pointer set up now. Of course, I'm going to have to index off of the tooth again, and I'm just going to come back on this corner here and index off of here, as long as everything will reach in there for me. So after a bit of messing around here, I have my pointer set up so that I can index from tooth to tooth. We, as you saw just a minute ago, we have our radius set on here, and now what we need to do is set the ends of our travel. So this is 120 degrees altogether. I want to stay at least 5 degrees shy on both ends. This end was a degree, if you recall. There's a degree of taper on here. So I'm going to stop this at 4 degrees. That should prevent the other side of the wheel from slamming into this tooth and making a mess of it. And now this way, I want to come all the way around and stop 5 thou shy of the 120 degrees. So I've set my end stops. I'm stopping 5 degrees shy of the 30-degree angle over here. And then I'm coming all the way around, and I'm stopping 5 degrees shy of the 0 degrees that the end is at. I'm just touching off now. There I'm touching. Now this whole thing will rotate out of the way. I can index to the next tooth, come back in, take that pass, index to the next tooth, come back in, take that pass, and I'm just going to keep working my way around. So there I'm all the way around. I'm going to set a 0 on my crossfeed. So I want to know where to come back to later. Now I'm going to wind this out so I'm not risking hitting the wheel anymore. And I want to run a dial on this radius that we're creating and make good and sure we've got adequate clearance on there. There, we're plus at the cutting edge, and it falls away minus behind the cutting edge. So we do in fact have clearance there. We can carry on and bring that radius right to size. Pop that bad boy out of there. Here it is, full on commitment. So here we are. Now, the pointer I made to do this is aluminum. So you can see a little aluminum scum where it's been dragging by as I index from tooth to tooth. And that's no big deal. The aluminum is super soft compared to this high-speed steel. It's not going to have any effect at all, except visually you can see a little drag, a little scuff mark there. So there's our end, nice and sharp. Don't know how the light's working for you there, but we have a real nice radius on this corner, and then our sides are nice and sharp. So this is 100% ready to go back to work. So at the beginning of this video, I mentioned that we had a new little thing on the little feature on this channel now. I was introducing today, and this is it. Well, what is that? Well, that is a board onto which one can put stickers. So a fellow YouTuber goes by Rusty Inventions, sent me this sticker, and I thought, well, what a neat idea. YouTubers, you know, showcasing each other's stickers, and so from now on in, any YouTuber that wants to send me a sticker, I'll put it right up here on the board.
And we'll give you a shout out.
Yeah. Well, that's it for today's video, guys. I hope you enjoyed the sharpening of this dovetail cutter. And if you did, please like, share, and subscribe. See you next time.